All right, let's talk about one of the most important technologies keeping our world from, well, falling apart. It's something you probably see every day but never really notice. We're talking about industrial coatings.
So think about it for a second. You have these massive steel structures, bridges, stadiums, pipelines, and they're just out there 24/7 getting hammered by the weather. What's stopping them from just rusting away into nothing? How do we fight back against nature's constant effort to break down everything we build?
Well, the answer is not just a bucket of paint. Not even close. It's a highly advanced protective coating. You can think of it like an invisible shield, one that's engineered at a molecular level and has to be applied with some serious scientific precision. This is where the real battle begins.
Okay, so let's get into it. To really get what these coatings are about, you have to think of it as a war against corrosion. You know, that natural process that wants to turn strong, shiny steel back into weak, flaky rust. And winning that war takes a lot more than just a brush and roller.
So here's the absolute bottom line. The whole point of an industrial coating is to create this perfect, unbroken protective film. This film is a barrier. It's the only thing standing between the steel and the air and moisture that are trying to eat it alive. And if that barrier fails, the whole structure it's protecting could fail too, catastrophically.
Now, you'd think this whole process starts with opening a can of the coating, right? Wrong. Success or failure is pretty much decided way before that even happens. The first and maybe biggest battle is against an enemy you can't even see, the environment itself.
And look, this isn't just a friendly suggestion. This is a hard and fast rule, laid out right here in the official guidebook for coating inspectors. If the conditions aren't perfect, the coating just won't work. It won't stick right. And that protective film we need, it'll be flawed from the very beginning.
So an inspector on the job is kind of like a field scientist. They're constantly watching all these different variables. They've got to know the air temperature, because that affects how fast the coating dries. They're measuring the temperature of the steel itself, and they're always watching the humidity and the dew point, which is basically the temperature where the air gets so saturated that water starts to condense out of it.
And this is definitely not guesswork. They're using specialized tools to get this data. On the left, you see an infrared thermometer. It gets a super precise surface temperature without even touching it. And on the right, that's a psychrometer, which measures the humidity to help calculate that critical dew point.
So after all that data is collected, everything, and I mean everything, comes down to one single magic number. 3 degrees Celsius, or 5 degrees Fahrenheit. This is the golden rule of this entire process. So why is that number so important? Because the surface of the steel has to be at least 3 degrees Celsius warmer than the dew point. If it's not, a layer of condensation, so thin you can't even see it, will form on the steel. Trying to paint over that is like trying to put a sticker on a wet window. It's just not going to stick. It is a guaranteed failure.
Okay, so let's say the environment is perfect. Now we can actually get to the coating itself. And this next part is less like painting and way more like doing a chemistry experiment, one that's on a very tight schedule.
This brings us to a really important idea called pot life. You know how some superglues come in 2 parts, a resin and a hardener, and once you mix them, you have to use it right away before it turns into a rock. That's exactly what pot life is. It's the countdown clock that starts the second you mix the chemicals. So here's the play-by-play. You take your base and your hardener and you mix them together at a very precise ratio. The second they combine, a chemical reaction called polymerization kicks off. It starts building these long, strong molecular chains that will become our protective film. The whole job becomes a race to get this reacting liquid onto the steel before it hardens right there in the pot. So we've wrestled the environment into submission, we've mixed our chemicals, and the clock is ticking. Now we apply the shield. And while there are a bunch of ways to do this, one of the most incredible methods literally involves spraying molten metal.
Yeah, you heard me right. It's called thermal spraying. You take a metal wire, usually something like zinc or aluminum, feed it into a special gun that melts it with a super hot flame or an electric arc. Then you blast those tiny molten droplets onto the steel. They instantly cool and lock together, forming a brand new metal skin that will sacrifice itself to protect the steel underneath.
This diagram is so cool. It shows you exactly what's going on inside that gun. You see the metal wire feeding in, it gets hit with fuel and oxygen to create insane heat, and then compressed air atomizes it, basically turns it into a spray and shoots it out. It's a tiny, controlled explosion in your hand.
And here it is in the real world. That bright glowing cone, that is liquid metal being sprayed by a seriously skilled technician. They are literally building a new surface right on top of the old one, pass by pass, creating a shield that's designed to last for decades. But hey, the job's not done just because the spraying is stopped. Now comes the most important part, the inspection. You have to answer the big question. Did it work? Was the battle actually won?
And you don't just eyeball it. Success is measured with science. Inspectors use magnetic gauges to make sure the coating is the exact right thickness. If it's too thin, it won't protect, and if it's too thick, it can crack. They can even look at it under a microscope or do tests where they literally try to rip the coating off just to prove how well it's bonded.
You know, this slide really brings it all home. It shows you that every single one of those steps we talked about has a direct consequence. Remember that invisible condensation? If you paint over it, the coating won't stick, period. If the air is too dry, some coatings can turn weak and powdery. Even a tiny bit of moisture in the spray equipment can ruin a whole batch. Every detail matters.
So the next time you drive over a bridge, just remember the invisible shield holding it all together. It's a shield that wasn't just poured out of a can, it was born from a deep understanding of physics, chemistry, and some seriously precise engineering. And that really makes you wonder, what other invisible science is out there, quietly protecting us every single day?